An American roulette wheel contains 38 slots, 18 red, 18 black, and 2 green. A casino has purchased a new wheel and they want to know if there is any evidence that the wheel is unfair. They spin the wheel 100 times and it lands on red 44 times, black 49 times, and green 7 times. We're going to be conducting a chi-square goodness of fit test here to determine if there is evidence that the wheel is unfair. Step 1 is to check assumptions and write hypotheses. The assumption is that each of the expected counts is at least 5. We'll find this later when we do the calculations of the expected values in Minitab Express. So we'll start with writing hypotheses. If the wheel is fair, then we would expect to get a red result 18 out of 38 times. Because the wheel has 38 slots, 18 are red. We would expect to get black 18 out of 38, and we would expect to get green 2 out of 38. Our null hypothesis then is that P of red is 18 over 38, P of black is 18 over 38, and P of green is 2 over 38. The alternative hypothesis is that at least one piece of I is not as specified in the null. Step 2 is to compute the test statistic. We're going to go to Minitab Express to conduct this test. I'm going to enter our summarized data. We'll have the counts and the color. In our sample, there were 44 red results, 49 black results, and 7 green results. I'm on a Mac, so I'll go to Statistics, Tables, chi-square, goodness of fit. Our data are summarized in a column. The observed counts are in the first column, and the category names, which are optional, are in the second column. The default in Minitab Express is to test equal proportions. So here with 3 colors, the null would be that the proportion in each group would be 1 over 3. That's not the case here. Remember, we had different proportions for the different colors. There's 2 different ways that we could set this up. We could use specified proportions, where we would have to enter the proportion, which would be the value between 0 and 1. What I want to do in this case is to use proportions based on historical counts. If the null hypothesis is true, then we would expect 18 red, 18 black, and 2 green. So those are the numbers that I'm going to enter in here. You need to be careful though, because Minitab Express is going to put these in alphabetical order, which is different from the order that we entered in the sample data. We would expect 18 black, 2 green, and 18 red. I'll go ahead and run this. Here are our results. We can check that assumption that all of the expected counts are 5 by looking at this first table. Expected counts are about 47, 47, and then 5.2632. So all of the expected counts are at least 5. We can use the chi-square distribution to estimate our sampling distribution. The table that we need then with the test statistic and the p-value is right here. I'll copy this back over and we'll continue working through our 5-step hypothesis testing procedure using these results. Here we have the output that we just obtained in Minitab Express. Our test statistic here is chi-square with 2 degrees of freedom equals 0.87. Step 3, determine the p-value. We can also get this from our output. P equals 0.6476. Step 4, make a decision. Assuming a standard 0.05 alpha level, our p-value is greater than alpha, so we fail to reject the null. Step 5, state a real-world conclusion. We failed to reject the null, so there is not evidence that this roulette wheel is unfair. In other words, there is not evidence that any of the proportions in the population are different from those that we would expect, given a breakdown of 18, 18, and 2 for red, black, and green, respectively.